Do you know that there was an ambitious project by the American government that turned out to be a disaster in the end? It was supposed to be the best bomber place of its time, but last, it was just an embarrassment. Welcome to your channel. If you're new here, then don't forget to subscribe and press the bell icon so you won't miss any future updates. With that note, let's get started. Midway through the 1950s, tensions between the United States and the Soviet Union reached their peak. Both sides possessed strategic bombers capable of flying halfway around the world to strike targets deep within enemy territory. The United States had developed a bomber force comprised entirely of jet aircraft. The newly introduced B-52 could transport large payloads over long distances, while the upcoming B-58 would attain supersonic speeds. However, neither would be sufficient against Soviet air defenses in an all-out war. Although the B-52 could reach the Soviet Union, it was too slow to compete with the newest generation of Soviet interceptors. The supersonic B-58 could fly as quickly as any interceptor, but its range and payload were limited. The Air Force desperately needed a new type of aircraft, a bomber capable of outrunning anything the Soviets could throw at it. In 1955, however, many questioned whether such an aircraft was even possible because it would necessitate employing fairly radical solutions, such as utilizing nuclear power to increase the range of an aircraft or exotic high-energy fuels to improve the performance of jet engines. The most practical solution appeared to be an aircraft that flew subsonically most of the way to its destination before jettisoning its outer wings and fuel tanks to make a supersonic dash. In contrast, aerodynamics, engine performance, and exotic materials advanced at a breakneck pace in the 1950s as aviation technology advanced at a breakneck pace. And this meant that the dash concept could be abandoned in favor of a design capable of supersonic flight for the duration of the mission. In 1957, the Air Force began developing a bomber of the next generation, and the performance objectives were lofty. It would have to fly at a speed greater than 3 times that of the B-52 at the height of 25,000 feet with a similar payload and range. Boeing and North American Aviation were invited to participate in a design competition. Boeing and North America submitted radical ideas that superficially resembled one another. Both aircraft were equipped with delta wings optimized for supersonic flight. However, Boeing was widely anticipated to win. During the Second World War, they constructed the venerable B-52 in a series of iconic bombers. North America represented the underdog. During development, however, their engineers discovered research that would give them a significant advantage. A little-known report describes the phenomenon known as compression lift. Whenever an aircraft exceeds the speed of sound, shock waves typically travel away from it. However, if the shock waves could be redirected beneath the wings, they would help generate additional lift. The North American entry promised to fly more efficiently at high supersonic speeds using this principle. The Air Force was likewise impressed. To Boeing's surprise, North America's design was chosen for development in 1957. The new bomber will be designated the B-70 and given the name Valkyrie. Engineers utilized cutting-edge technologies to construct a 260-ton bomber capable of outrunning a fighter jet. 6 afterburning turbojets were fed air through a sophisticated intake to make this feat possible. The engines have been optimized for optimal performance at high supersonic speeds, and they were so potent that even if one failed, the Valkyrie could still maintain Mach 3 and accomplish its mission. The Valkyrie had one of the highest lift-to-drag ratios of any manned aircraft due to its innovative aerodynamics, which included compression lift. Wings with variable geometry increased stability in compression lift. Takeoffs and landings could be extended to their maximum length. At low supersonic speeds, the angle is 25 degrees, and at multi-Mach speeds, it is 65 degrees. At 3 times the speed of sound, however, the airframe's kinetic heating would be so intense that it would soften conventional aircraft aluminum. To cool the aircraft's interior, engineers created a revolutionary fuselage skin and circulated fuel throughout the airframe. Even at an altitude of 75,000 feet, the Valkyrie's cockpit was fully pressurized and equipped with an innovative encapsulated escape system. It meant that the bomber's crew of 4 did not need to don cumbersome flight suits, allowing a Valkyrie crew to take off in just 20 minutes. The Valkyrie was capable of delivering a nuclear payload to any location on Earth within hours, a performance that was truly extraterrestrial, and the bomber would represent America's deterrence through strength strategy. The first experimental XB-70 prototype was unveiled in May of 1964, and the flight testing began in the months that followed, and it would soon be joined by a second and third prototype, both of which were already in development. However, it was clear from the beginning that things would not proceed smoothly. During the initial ground tests, there were so many technical issues that the first flight was delayed by several months while engineers resolved them. The XB-70 wasn't ready to take its maiden flight until September 21st, as the space-aged bomber lifted off for the very first time. Cheers could be heard. However, the celebrations were brief. Due to a hydraulic leak, the landing gear was unable to retract. Eventually, one of the engines overheated, necessitating a shutdown. As the prototype returned for a landing, a malfunctioning brake caused a tire to blow out and catch fire. It appeared that as soon as one issue was resolved, another would arise. On October 12th, the XB-70 broke the sound barrier for the first time, edging just above Mach 1 for the first time. As flight tests continued, however, the paint began to peel off the fuselage and control surfaces, and the aircraft soon appeared as though it had flown through a sandblaster. The paint was repaired and the XB-70 accelerated to greater speeds. However, the faster it flew during each test flight, the more serious the problems appeared to become. At Mach 2.6 during the prototype's 12th test flight, the horizontal splitter tore off and was sucked into the engine duct, destroying 4 engines. The pilots landed safely, but it was necessary to replace all of the engines. Finally, on October 14th, the aircraft was given permission to reach Mach 3 speed. A large portion of the wing's leading edge broke off just 2 minutes into the flight, necessitating yet another emergency landing. After that, the first prototype could no longer fly faster than Mach 2.5. The development of such a cutting-edge aircraft was bound to encounter obstacles. However, a much larger issue loomed over the program. From the very beginning, it was questioned whether the Valkyrie would be truly safe for Soviet air defenses, because surface-to-air missiles, which were introduced in the mid-1950s, rapidly became the most effective way to protect airspace. In the 1960s, the Soviet Union had thousands of these missiles, which could strike targets beyond the altitude of the XB-70. With the introduction of intercontinental ballistic missiles in the late 1950s, nuclear warheads could now be delivered much more quickly and affordably. In just a few years, missile technology rendered virtually obsolete the world's most advanced bomber. With the XB-70's strategic value in question, engineers scrambled to maintain the aircraft's relevance, exploring radical ideas to transform the bomber into a missile launcher, a spacecraft launch platform, or even a supersonic aerial refueler. A proposal to convert the bomber into a Mach 3 supersonic transport was even more absurd. However, these concepts proved insurmountable, and the program was drastically scaled back, eventually being reduced to a 2-aircraft research project as a bare minimum. With millions already spent on development, however, the program continued. Moreover, NASA joined the Air Force in flight testing in 1966, utilizing prototypes to collect valuable data on supersonic flight. By then, the second prototype had proven to be a significantly more capable aircraft. On May 19, 1966, it surpassed Mach 3, proving its ability to cruise at 3 times the speed of sound for 30 minutes. After nearly a decade of development, one of the most ambitious aircraft in the world was finally meeting expectations. But tragedy would strike just weeks later. The second prototype was joined by 4 other aircraft for a photo opportunity on June 8th. Unpredictably, minutes into the flight, one of the trailing aircraft collided with the XB-70, destroying it instantly and severely damaging the Valkyrie's vertical stabilizers. The Valkyrie continued to fly straight and level for 16 seconds before spiraling back to Earth. 2 test pilots and a billion-dollar aircraft were tragically lost in a matter of seconds. It was a devastating setback for the program, and NASA and the Air Force were forced to continue the research with the significantly less capable original prototype. The XB-70 was a feat of engineering. Even though it never joined the American bomber force, it had a significant impact on the Cold War as a result of learning in 1955 that the United States was developing a supersonic long-range bomber. The Soviet Union rushed to develop an equivalent weapon, and it would become one of the most intimidating-looking aircraft ever constructed. But appearances can be deceiving. In an effort to compete with the United States, the Soviets produced an embarrassing failure, one which they would conceal for decades. But that's a story for some other day. Well, this was all for today. Do let us know your thoughts in the comments down below. Also, don't forget to subscribe to our channel, and I'll see you at the next one. Bye-bye.